In this video and the 4 following videos, we make some statements and ask some questions. Let's look at a few preliminaries. What is an even number? Well, here's a list of a few even numbers. Can you write down a formula for all even numbers? Well, 2n, where n is a positive whole number, will give the numbers above. Of course, 0 and negative even numbers exist, so more generally, 2n, where n is an integer, represents all even numbers. What do we call the ones in between? Well, those are the odd numbers, 1, 3, and so on. Can you write down a formula for odd numbers? Well, just like with even numbers, 2n plus 1, where n is an integer, will give all odd numbers. And the focus for these videos will be on non-negative integers, so 0, 1, 2, and so on. What is a prime number? Well, a prime number p is any whole number greater than 1 which is only divisible by the number itself and 1. So the factors of p are only 1 and p. Can you give some examples of prime numbers? Well, these are the first few, and you will see them appearing at the bottom of the screen for all of the videos. Now, all whole numbers can be expressed uniquely as the product of primes. For example, 6 is the product of the 2 primes 2 and 3. 12, on the other hand, is the product of primes, can be written uniquely, but we've had to use 2 twice. Similarly, 60. So we can say that primes are the building blocks for whole numbers. Now, is 2 the only even prime? Well, of course, because all even numbers beyond 2 are clearly divisible by 2. Can you write down a formula for prime numbers? Well, no formula has yet been found which will give all prime numbers that are known, and no formula exists which only gives prime numbers. So this is an open question. Now, how do you check whether a number is prime or not? Well, you divide by all the primes you already know up to approximately the square root of that number, and if it's not divisible by any of those numbers, then that number itself must be prime. What is the largest prime you know? Well, this is the largest one found so far, and it's got over 24 million digits. How many primes are there? Well, there are infinitely many primes. So we're going to prove now that there are infinitely many prime numbers, so however long you spend looking for prime numbers, you will never find them all. So let's suppose, to prove that there are infinitely many prime numbers, the opposite of this statement, and get a contradiction. So suppose there are only finitely many prime numbers. And let's suppose that list of finitely many prime numbers is P1 to Pn. Now take all of those prime numbers that you know to exist and to be the only ones under our assumption, and add 1, then we form a new number m. Now m itself is not divisible by p1 because it gives a remainder of 1 when dividing by p1. Similarly, m is not divisible by any of the other primes. So starting with m, which is the product of the only prime numbers we assume exist, plus 1, then either m itself is prime, or it can be written as the product of primes. Well, m is clearly larger than 1, so it's either prime or the product of primes. Suppose first that m is prime. But if m is prime, it's larger than the list of primes we've already got, so it's a new prime, and yet they were meant to be the only primes that exists. So that now gives us a contradiction. So clearly in this case, m cannot be prime. So with that product of primes plus 1, then m must instead be a product of primes. Let's suppose q is one of the primes in that product. That means m must be divisible by q. On the other hand, we've already seen that m is not divisible by any of the numbers in the list, p1 to pn, which are assumed to be the only prime numbers. And so again we've got a contradiction with the assumption that that list included all prime numbers, because we appear to have found yet another prime, q, that m is divisible by, and yet we knew that m was not divisible by any of the primes that exists. So since our assumption that there are finitely many prime numbers has led to a contradiction, the opposite must be true, and there must be infinitely many prime numbers. So before you move to the next video, you need to download and print the 2 PDF documents with questions and the list of primes before you move on. You need to find something to write with, and then you need to watch the video.